Scientific notation. So what's scientific notation for?
Writing big or small numbers.
Yeah, okay, writing inconveniently big or small numbers. A lot of times it happens when we're dealing with stuff in, science. What's an example of a really big number you deal with sometimes?
Avogadro's number.
Avogadro's number, or something in space, like the mass of Earth in kilograms, or, really big numbers that would have lots and lots and lots of zeros. What's an example of a really small number you might deal with? Yeah, maybe the mass of an atom or the mass of an electron or something like that, right? Perfect. Okay, so, and you can, again, stop me if this is, if this is just too redundant and I'm just wasting your time. So remember, scientific notation, always it's written in this form. It's written as some number times 10 to a power, right? A times 10 to the R, where A we'll just call the number that sits out front. So what are the characteristics of scientific notation? The number could be positive or negative, but the absolute value of A has to be greater than or equal to 1 and less than 10. So could it be 1?
Yes.
It could. It could be 1, but could it be 10? No. Right. We can only have one digit before the decimal in this number that goes before the 10, right? And then the exponent just has to be some integer, positive or negative. Okay? And then remember how this works. Real simple. When you're writing a number in scientific notation, all you're going to do is you're just going to move the decimal point from its original position in the number until you end up with a number that fits those criteria we just talked about, right? Where the number is greater than or equal to 1 and less than 10. It's absolute value at least, right? It could be a negative number, but the same rules apply. We're just going to count the number of places we move the decimal, and that tells us what the exponent's going to be, right? If we start off with a really big number and we have to move the decimal to the left to make it smaller, well then we know that we're going to get a positive exponent because big numbers use positive powers of 10 to write them, right? If we start off with a really small decimal and we have to move the decimal place to the right to create a number that's greater than or equal to 1 and less than 10, then that means that the power becomes negative. So quick examples would be like this, right? Here we've got a big number, much bigger than 10. And in this case, we had to take this decimal and we had to move it to the left 3 places. So we end up with, to get a number that's greater than or equal to 1 and less than 10. So 4.7 is the first one we would get, right? When we move it to the left. So that's the number we get out front, and the number of places we moved it to the left becomes the exponent. Give me 1 to 5 on that. I'm sure this is stuff you've done many, many, many times. And then something like this, a really small number. This time we've got to move the decimal 1, 2, 3, 4 places. Is that right? 1, 2, 3, 4. Yeah, 4 places to the right to create a number greater than or equal to 1. And so we get the exponent -4. Okay? Going the other direction, what if I wanted to turn this top number into standard notation instead of scientific notation? How far and in which direction am I going to move the decimal?
3 to the right.
3 to the right, because I know we're multiplying by a positive power of 10, so it's going to be a big number. So I got to move this thing 3 places, and there's my number. How about this guy? Okay, I know it's a very small number, so I'm going to have to go 5 to the left, which is going to give me a decimal in front of 4 leading zeros, right? So that's what we end up with. Okay, good? All right, I'm done with that. You guys can work. You got another assignment in 6.2 covering